Okay, good day. So today, this is our lecture 5 for General Physics 2, and we're going to discuss another type of circuit analysis, but we'll focus on this specific component, resistors. The learning competencies to be discussed for this lecture are the following. Before we start with our main topic, let us recall what we have discussed on our previous lecture. We have known that there are three factors affecting or which we could see in an electricity. Okay, so there is voltage, resistance, and current. Okay, these three factors that we have discussed, the relationship of this is described or demonstrated on the law, okay, made by George Simon Ohm, which we know as the Ohm's law. Okay, Ohm's law is the relationship between voltage, current, and resistance in any DC circuit or any DC electrical circuit. Okay, take note that Ohm's law is only applicable for direct current circuit. Okay, so according to Ohm's law, current I measured in amperes is equals to the voltage V over resistance R. So based from this equation, we can conclude that the current is directly proportional to voltage and inversely proportional to resistance. Okay, and ano po ba ang ibig sabihin ng voltage, resistance, and current? Okay, voltage is the electrical potential of a specific or stored electrical potential in a given circuit. Okay, so while current is the motion or it is described as any motion of charge from one region to another. So we have two types of current, direct current and alternating current. So DC current is used for small voltage rating gadgets or appliance, while alternating current is used for on a large scale basis. For example, a residential area, okay, manufacturing company, and etc. Okay, so how do we measure the amount or the value of how much current is a circuit? So we can compute that using this equation. So whereas current is equals to the quotient between charge and time. So based from this formula, current as the measurement of how much charge travel on a specific time. Okay, then we move on to resistance. Okay, so resistance is equal to the ratio of voltage to current. So resistance is the capability of circuit or a material to resist the flow of current. So resistance R measured in ohms is equals to V over I. Okay, so this is according to Ohm's law. Okay, so any object or any material, specifically metals, also have its own value of resistance. So that is computed using this equation R is equals to rho multiplied by L over A. So based from this mathematical expression, it is defined or we can see that the value of the resistance of a specific material depends on the type of the material used based from the resistivity of that specific material, then the size, the length of the material, and then A, which is the area, okay, expresses the shape of the material. Also, the increase or the change in temperature also affects on the value of the resistance. Okay, so the mathematically express the increase or the change of resistance due to the change in temperature, we use this equation. So when the temperature increases on a given environment, okay, for specifically for metals, resistance also increases. So directly proportional po, take note in metals, ang resistance and temperature. Pag increase ng resistance, pag increase ng temperature, pag increase din po ng resistance. So how that happens, okay? So if nag-i-increase yung temperature natin, okay, mas umiinit yung panahon, the charges or the atoms inside a metal becomes excited. Okay, once na-excite po sila, nakaramdam sila ng heat, okay, so nag-i-increase din yung speed nila. And once na nag-increase yung speed nila, okay, the vibrations between the moving or increasing speed of the charges affects the value of the resistance. Kasi nami-measure po natin ang resistance by the vibrations produced by our charges. So in accordance to Ohm's law and current, voltage, and resistance. Okay? So, kailangan din po nating malaman yung amount of energy na na-absorb at nagpo-produce ng isang circuit. Okay? And na-measure po yan through power. Power measured in watts. Okay? Power is equals to voltage times current, or power watt is equals to IV. Okay? So, since discuss na natin or na-recall na natin yung ating previous lecture, pwede tayo mag-move on with circuit analysis. So, as we know, okay, based dun sa capacitor lecture natin, meron tayong dalawang klase ng circuit. Okay? Series and parallel circuit. Ano po ba ang difference nitong dalawang circuit na to sa isa't isa? Okay? Sa series circuit, components are connected end-to-end. Okay? What does that mean? Okay? So, ito yung example natin. Okay? There is only a single path of current to flow. So once kunwari, itong load na to or itong light bulb na to, hindi na siya gumana. Okay? So tinanggal mo siya dun sa circuit, the tendency of this three other circuit would not flow. Why would that happen? Because according to our formula, there is only a single path. Okay, so once na hindi na nag-work yung isa, the rest would not work. Okay, and then on the other hand, for parallel circuit, okay, both ends are connected or both ends of the component is connected together. There are multiple paths for the current to flow. So, paano natin siya ipapakita based dito sa ating example circuit? So, if itong ating ikalawang component, okay, nawalan siya ng connection, tinanggal natin siya dito. Okay, so the rest would work. Magwo-work pa rin po yung ibang tatlong component kasi merong multiple paths na pina-follow or nag-flow yung ating current. Okay? So, from our source, nahahati po yung currents niya dun sa ating mga junction or sa ating mga nodes. Okay? So, ngayon, i-analyze naman natin ang mga resistor na connected in series. Okay? So, in order for us to get the total resistance on the specific circuit, okay, ito yung equation po na gagamitin natin. R total is also equivalent to the equivalent resistance of that circuit, equal po sa summation ng lahat ng values ng resistance dun sa, or loads dun sa circuit mo. Okay, R1, R2, R3. Okay, and so on. Kahit ilan pa po yan, again, summation lang po siya. Okay, that is for series circuit. And then, sa voltage naman, same pa rin yun. Same pa rin yung concept na papasok dito. Na kapag series siya, okay? So, yung summation ng lahat ng voltage drops mo dun sa specific loads mo or sa each load mo would be equal to the value of your source voltage. Okay? And while the current, since sa circuit natin, kapag series siya, isang path lang yung tinitake niya. So, meaning, the value of each current dissipation sa loads mo ay equal sa total value ng iyong current. Okay? So, try natin siya dito sa ating unang problem. Okay? So, we have a 3 resistors here connected in series. Okay? So, ang source voltage natin is equals to 12 volts. Okay? So, hanapin natin yung total resistance. So, total resistance equals to R1 plus R2 plus R3. Okay? Kasi tatlo lang yung resistors natin. Okay? 220 ohms plus 470 ohms plus 1.2 kilo ohms. Okay? Take note, itong 1.2 kilo ohms is equal to 1.2 times 10 raised to positive 3 ohms. So, the total resistance is equal to 1.89 or 1,890 ohms. Pag scientific notation, 1.89 times 10 raised to positive 3 ohms. Or, kapag engineering notation naman is 1.89 kilo ohms. Okay, I suggest that you train yourself or sanayin nyo po ang sarili nyo na express yung mga final answers nyo, okay, sa either scientific notation or sa engineering notation. Kasi bakit po mas maganda kung naka-engineering or naka-scientific notation siya? Kasi mas nababawasan natin or mas dumadaming significant figures na babawasan natin yung calculations uncertainty or errors in calculations. Okay? So, take note of that. And then, after we get the total resistance, let's get the total current that passes through the circuit, IT. Okay? So, IT is equals to, let's use Ohm's law, VT over RT. So, yung VT natin, equal siya sa 12 volts. Yung RT natin, so itong na-compute natin, let's use 1.89 times 10 raised to positive 3 ohms. So, IT, or total current, is equals to 6.3492 milliamperes. Okay? So, next po, compute din natin how much power is, ano yung power source natin. Okay? Power source, or total power is equals to IT, VT. So, IT natin is 6.3492 milliamps. Okay? Multiply by 12 volts. Total power is equals to 76.1905 milliwatts. Okay? So now, sulat natin dito, meron na tayong RT, IT, and PT. Okay? So, i-compute naman natin what would be the voltage drop and current dissipation or current that flows through individual loads. Okay? So, how do we do that? So, i-apply natin yung concept na nabanggit natin na kapag series siya, same ang value ng current. Okay? So, IT is equals to I1 is equals to I2 and equals to I3. So, lahat po sila, yung I1 natin, IR1, IR2, and IR3 is equals to 6.3492 milliamperes. Okay, so i-compute na lang natin ngayon is voltage. So, let's start with resistor 1. Our R1 is equivalent to 220 ohms. Okay, so para ma-compute natin yung V1 or V at R1, so gamitin natin yung I1, R1. So, multiply lang natin siya, 6.3492 milliamperes multiply by 220 ohms. Okay, V1 is equals to 1.3968 volts. Okay, so next, i-compute din natin how much power is absorbed by our resistor 1. So P1 is equals to I1 V1. Okay, ang I natin is 6.3492 milliamperes. Okay, times 1.3968 volts. Okay, equal po siya sa 8.8687 milliwatt. Okay, now let's move on with at R2, which is equal to 470 ohms. Yan. So, I1 natin, I2 natin, equal lang din sa total, which is 6.3492 milliamps. Okay? So, i-calculate natin yung V2 using I2, R2. Okay? So, 6.3492 milliamps multiply by 470 ohms. Okay? V2 is equal to 2.9841 volts. How about the power absorbed? P1, I1, V1. Ay, sorry, P2 na pala tayo. P2, I2, V2. Okay? So, 6.3492 MA. Okay, multiply by 2.9841. So, ang power absorbed by the resistor is equals to 18.9468 milliwatt. Let's rewrite our totals, the value of our total. So, RT, 1.89 kilo ohms. IT is equals to 6.3492 milliamperes. And then we have PT, which is equals to 76.1905 milliwatts. Let's continue with R3 na equal sa 1.2 times 10 raised to positive 3 or ohms or 1.2 kilo ohms. I3, so yan, equal lang din, milliamps. Okay, V3 is equals to I3, R3. So yan, multiply na natin itong dalawa. So magiging sagot po ay 7.61. So i-multiply na po natin itong dalawa. V3 is equals to 7.61904 volts. Sorry, 904 volts. Okay, V3 naman is equals to I3, V3. Yan, so ipag-multiply naman natin itong dalawa. V3 is equals to 48.3748 milliwatts. Okay? So, let's check. Checking muna tayo. Okay? Tingnan natin kung tama ba yung ginawa natin. Okay? So, sa voltage, according to our concept, yan, VT, ang total voltage daw, dapat equal daw siya sa lahat ng values or voltage drops. Okay? Ng individual loads mo. So, kung i-add po natin yung V1, V2, V3, equal po ba siya sa 12 volts? Okay? So, i-add natin yung 1.3968 plus 2.94 or 9841 plus 7.61904. So, the total value is approximately equal to 12. So, yung makompute mo po dyan is 11.999 and so on. Okay, so tama po ang ating mga na-compute na individual voltage drops. Okay, how about power? Paano natin mag-check yung sa power? Power, PT, same lang din po. Since according to our definition, power is a measurement of how much energy is absorbed and used by that specific circuit. Okay, so the individual or the summation of the individual values of the power absorbed is equal or should be equal to the total power source. Okay, so ano ba ang total power natin? It is equals to 76.1905 milliwatts. So kung i-add mo to, P1, P2, and P3, you would be getting, okay, similar value for the PT, which is 76.1905 milliwatts. Okay? So, that is for series circuit. Kapag parallel naman, yan, let's move forward with parallel circuit. Okay? So, in getting the total resistance for parallel circuit, okay? So, ito yung ginagamit nating equation. 1 over R equivalent is equals to 1 over R1 plus 1 over R2 plus 1 over R3 or, okay, RT is equals to 1 over R1 plus 1 over R2 plus 1 over R3 raised to negative 1. Okay? So, sa voltage source natin, okay, since parallel circuit po to, same po ng concept natin with the capacitors. The source voltage is equals to the individual voltages of each load. Okay? While sa current naman, okay, kasi since meron tayong dinadaanan dito multiple paths, so yung value ng current from the source is nahahati po depende sa ating mga loads. Okay, so I total is equals to I1 plus I2 plus I3. Okay, so ito po ay derivation lang from Ohm's law. Okay, kaya po V source yung nasa taas dahil according sa concept natin, V source is equals to V1, V2, and V3. Okay, so try po natin siya dito with our parallel circuit example. Okay, let's compute for RT. RT is equals to 1 over R1 plus 1 over R2 plus 1 over R3 raised to negative 1. Okay, equal siya sa 1 over 470 ohms plus 1 over 2.2 kilo ohms. Okay, take note, kilo ohms is times 10 raised to positive 3 ohms. Okay, plus 1 over 3.3 kilo ohms raised to negative 1. Okay, RT is equal to 43.2785 milliamperes. Okay, IT naman is equals to PT over RT. Yan, 15 volts over 43.2785 milliamps. Okay, ang milliamps po ay times 10 raised to negative 3. Okay, IT is equals to, this should be 346.5922 ohms. 346.5922 ohms. Okay, so yun pa lang pala ang value ng current, 43.2785 milliamps. Okay, so next po ay PT. PT is equals to IT VT. Okay, 43.2785 milliamps multiplied by 15 volts. PT or total power is equals to 649.1779 milliwatts. Okay? So, ito yung mga totals natin. So, paano naman natin isosolve yung individual current tsaka individual voltages? Okay? Mag-start tayo sa voltage. So, since sabi nga natin sa concept natin, yan, V source is equals to V1, V2, V3. So, dito, since parallel sila lahat, VT is equals to V1, is equals to V2, is equals to V3. So, equal po silang lahat sa 15 volts. How about I? So, ito yung i-compute natin. IT, okay, is equals to I1 plus I2 plus I3. So, ito po yung gagamitin yung equation. Yan. Okay? And then, for PT naman, PT is equals to I1 V1 plus I2 V2 plus I3, V3. So, same lang din po dito. Kahit po yan ay parallel or kahit po yan ay series, yung PT po niya ay just a summation of the current and voltages. Kasi the energy doesn't matter on a given circuit. It is just absorbed or released. Okay? So, that would be for parallel. Okay, in order for us to easily analyze a circuit, meron pong rule tayong ginagamit dyan or law. So, that law is known as the Kirchoffs law. So, this law is divided into two rules. The Kirchoffs voltage law or KVL or the Kirchoffs current law or KCL. So, ano yung difference ni KVL kay KCL? Okay? So, according to Gustav Kirchoff, a German physicist, KVL is the sum of all voltage drops in a series circuit equal to the total voltage of the or total applied voltage. So, si KVL, okay, magagamit lang po natin yan kapag series circuit. So, ito yung concept na alam natin. Ay, may tawag pala doon. So, ang tawag pala doon is KVL, where the source is equals to the summation of all voltage drops per each load. Okay? Next po ay yung KCL or Kirchoff's current law. It states that the total current in a parallel circuit, okay? So magagamit po natin to kapag parallel is equal to the sum of the individual branch current. So ito yung concept na ginagamit natin for parallel where I total is equals to I1 plus I2 plus I3. Okay? So para mas madali nating ma-analyze na kung KVL ba or KCL yung gagamitin natin on a given circuit, meron dyang mga sinusunod na rule. Okay? The first rule is in relation to KVL, voltage rule or conservation of energy. Okay? Or in other terms, tinatawag nating loop rule. So sa loop rule, hinahanap po natin yung potential or sum of the potential drops for each resistor na yung sum daw nila ay equal sa potential rises or sa source potential natin from the battery around a closed loop. Okay, so ma-apply lang po natin tong loop rule sa closed circuit. Okay, so yun po, maglo-loop lang tayo. Iti-trace natin kung ano yung voltage loop ng ating or ano yung paraan ng pag-ikot ng energy, okay, doon sa ating circuit. Okay, so paano natin ito ma-identify yung direction ng loop using conventional, okay, using conventional current flow. Okay, na nagsa-start tayo sa positive terminal papunta sa negative. Okay, so yun yung loop rule. Second rule is yung current rule. Okay, current rule ay may relation po to sa KCL. So, dito po, ang inaano po niya, ina-achieve niya is yung conservation of electrical charge and also known po itong rule na to as junction rule. So sa junction rule, since KCL po siya, ang inaano dito is the amount of currents that passes through a junction or a circuit. Okay? So sabi po ni junction rule or according to junction rule, the sum of the magnitudes of the current going into the junction, okay? Yung junction po dito is what we know as nodes. Okay, is equals to the sum of the magnitude of the currents leaving the junction. So, dito po, sa junction rule, everything that comes in must comes out. Okay, so yung I1 natin dito, for example, dumaan siya dito sa junction or sa node natin. Okay, so yung value ni I1, okay, kung wala siya yung pinakamalapit sa terminals or siya yung pinakamalapit sa source. So yung value ni I1 ay equal din po sa I2 and equal din sa I3. If we would be getting this whole junction, okay, or the value or the magnitude of the currents that passes through these branches 1, branches 2, and branch 3, okay, equal po siya sa I1, I2, and I3. So, yung summation nilang lahat ay equal sa 0. Okay? So, try po natin siyang i-apply dito sa example na to. So, ang una po natin gagawin dyan, ang technique is to analyze the circuit by demonstrating the loops, okay, the individual loops based from KVL. Okay? So, dito meron tayong dalawang voltage source, E1 and E2. Okay? So, based from conventional current na from positive to negative, so yung una nating loop, I1, okay? Ito yung direction niya. Okay? Yung second loop naman natin, since positive to negative, kabaligtaran po nung isa or opposite nung isa. Okay? Ang next po is, choose the direction of the current to flow on each loop and applies Kirchoff's junction rule. So, yun yung second step. Okay, dito, meron tayong isa lang junction. Okay, this is our node. Okay? So, mapapansin natin, meron ditong current, di ba? From I1 may dumaan ditong current ni I1, tapos dito naman may dumaang current ni I2. So, what would be the value of I3? So, I3, diba, according to Kirchoff's junction rule, I in is equals to I out. So, ano yung pumasok? Okay, dito sa node na to. So, ang pumasok is I1 and I2. So, meaning, ang value ng lumabas dito sa junction na to, which is I3, ay equal sa I3. So, pwede natin ma-conclude na yung pinagsamang current from I1 and current I2, okay, is equals to I3. Okay, so and then, pwede na natin ma-compute yung total current na nag-leave dito sa junction na to. And that's how Kirchoff's voltage law and Kirchoff's current law is applied on a given circuit. Okay, so if ever na meron po kayong mga questions, you may reach through me. This law and rules may be applied to easy analyzing a given circuit. Okay, so that would be all for this lecture. Goodbye and thank you.